Hi there everybody, today we're going to look at looking at the volume of a compound 3D shape. Again, like other lessons, if you're not quite sure of volumes of specific shapes, then this is probably not a good idea to start on, so please look at volume of pyramids, volume of cones, volume of prisms and all those kind of different things, and cuboids as well, alright, because you need all those kind of skill sets to be able to do a compound 3D shape. But so I'm going to walk you through one anyway in terms of how we approach it. And then of course you can go away and practice. Alright, so what we've got, let's have a look at the example. We've got what looks like a cuboid at the bottom and then a pyramid at the top. It's not a square base, is it? Because it's not a square at the bottom. So what we've got is a variety of different kind of information that we need to kind of get from it. Alright, so first things first. Right, we have the cuboid at the bottom. It's probably better. Oh no, we're going to start with height of the pyramid. All right. Why do we need the height of the pyramid? Well, to work out the height of a pyramid, the volume of a pyramid, what I need is the area of the base times by a third, and then times it by its perpendicular to height. Well, I don't have the perpendicular. I have its slope by the looks of it. So in terms of obviously getting its slope, so what you're going to do, difficult to kind of visualize, is that you're going to put a line right down the middle, all right, and you've got this bit. So I've got 6 squared, and then because this distance here is 4, it's going to be half that, and it's going to be 2 squared. So using Pythagoras backwards, so 6 squared minus 2 squared square rooted, this is what I've written down, is going to give me the height of this, all right, which is 5.65. So already right into this kind of first kind of question, not a particularly nice one, it's now talking about giving you the slope rather than actually the perpendicular height. So I needed to work out the perpendicular height. So if you're not quite sure how I've gone about doing that, then please look at Pythagoras in 3D or revisiting Pythagoras, all right, because essentially that's where that's going to come from. All right, so we've got the height of the pyramid, which is 5.65. So the area of the pyramid, or the base of the pyramid, here, so we've got 4 and 8, so it's 4 times 8, which will be 32 centimeters squared, and the volume of the pyramid therefore is going to be a third times 32 times 5.656, which we've got written there because it's a third times the area of the base times its perpendicular height, which is going to give me 60.339 centimeters cubed. Now we are talking volume. All right, so that's the volume of the pyramid at the top. Well, the volume of the cuboid is much more straightforward. It's 5 times 8 times 4, which is going to give me 160, and of course the total volume is the two combined together, which would be 220.34 centimeters cubed. All right, so I think the hardest part of this one was that top bit, but ultimately if you've got a compound 3D shape and look at the volume, then of course you need to be able to work out the volume of any 3D shape, no matter how hard it can be. All right, and certainly this top one was not the easiest one at all, because you weren't given the height, you were only given the slope. Okay, which is why I had to do some Pythagoras in there. So please go back to maths-school.co.uk. There's a link at the bottom. Do some practice questions on there. Obviously, the more practice questions that you do, obviously the better you are going to be. All right, thanks for listening.